Once the requirements have been defined, the user can continue with the design by using the Wireless Deployment Planning tool. This tool is used when wireless devices are required in the building. It enables the designer to select the optimal configuration, number, position and topology of sensor, repeater and gateway devices in order to maximize link quality while minimizing the overall infrastructure cost. The BASON provides a logical representation of the building environment. However, it does not provide the geometric description, i.e. physical positions of walls, windows or devices. If the building model was not previously defined within the Wireless Deployment Planning model repository, it can be imported or drawn using the Environment Modeling tool. This tool facilitates the import of standard drawing formats such as AutoCAD. By selecting the AutoCAD file, the user can define the types of walls and associated material types. To make it easier for the user, a number of predefined material types are specified and include heavy, light, glass and metal. These material types detail the building structure and are an input to the prediction of signal coverage used by the design tool. Alternatively, the user can use the custom drawing tool to specify changes in the environment, such as new walls or doors. The floor plan is saved and can be used as a common environment description by all other tools in the toolchain. Once the environment is defined, the user can open their browser and log into the Wireless Deployment Planning tool. From here, the user can select to design and open the floor plans where they need to deploy their wireless devices. Once the environment is loaded, the user needs to then specify the requirements for their sensor devices. To expedite this process, the user can load previously defined sensor requirements that have been stored by the set tool in the BASON. The user can load all device instances that have been defined during the planning process. This includes the name of the device, the logical location and the associated floor plan. The user can then define the physical location of the devices on the map. This can be achieved automatically by selecting Auto Place on Map, where the tool defines the position based on the location defined during the planning phase. Alternatively, if the location is not found by the tool, the user can manually place the device by pointing and clicking on the map. At any point, the user can update the device position on the map. Using the tools provided, the user can select and move an existing device, or alternatively add a new device, all with a simple point and click process. With the sensor locations defined, the user must now define candidate zones. A candidate zone represents potential positions for sensors, repeaters or gateways. It can be defined as a point, line or polygon. By defining these zones, it creates a search space for the optimization engine. As a result, the tool can automatically optimize the number of repeaters and gateways required and ensures a robust communications infrastructure based on the site-specific constraints. Each zone has its own properties where the user can specify the type of technologies that can be deployed in the zone, what role this device can take in this location, for example sensor or repeater, and if predefined, the user can specify the specific current role. A set of these candidate zones forms the basis for the automatic optimization algorithm. At this point, when the sensor locations and candidate zones have been specified by the user, they can quickly evaluate a specific configuration within the floor plan. This is achieved by placing gateway devices and evaluating the topology of the specified configuration. Links are connected based on the sensitivity threshold defined for each device. If, for example, some nodes are not connected as a result, the user can move the devices and quickly see the impact of the change on the network configuration. The user can also use the tool to assess the signal coverage in the floor. The deployment planning tool uses a array launching based propagation model known as the motif model. Using these approaches, the user can quickly assess multiple configurations to get an insight into how the network connectivity will be in the environment without having to be on site. Even with the tool, manual tuning to device placement can be a difficult process, especially if the environment is large. Therefore, the Wireless Deployment Planning tool provides an automated device placement algorithm which will optimize the number and position of gateway and repeater devices driven by the placement constraints defined by the user. In this example, the results of the optimization process proposes that a single gateway and the addition of one repeater is sufficient to ensure all nodes are connected in this floor plan. The automated approach of the tool minimizes the effort and expertise required by the user when planning their wireless sensor network for their building. The design can then be saved and a deployment plan generated for the installer of the wireless system. allowing them to place the devices in the desired position to ensure a reliable network is achieved. The system model or BASONT is also updated with the physical positions of the devices to ensure a consistent view of the design is maintained.